Uh, Good morning, dear students. In the last period, we have studied about the nomenclature, isomerism, and introduction and various uses of the amines. In this period, we want to study about the preparation of amines. So, let's start our discussion on the preparation of the various amines. Let's look at that. Amines are prepared by the following methods. Let's look at the reduction of nitro compounds. So nitro compounds are reduced to amines by passing hydrogen gas in the presence of finely divided nickel or palladium or platinum. So these are the metals which are used um, as a compound or used as a catalyst, and this is how we finally convert the nitro compounds into the um, amines. So we can do it, or we can convert the nitro compounds into the amines by just using the various catalysts, and then by using these various catalysts we can easily do it, or we can convert the, so which are the catalysts? The finely divided nickel and platinum or palladium. My dear students, I am taking pause because there are few students uh, admitting into the class, and for allowing them to enter into the class, I need to stop. Just a minute. I shall be mm, back. Yes. So now let me move forward and make you understand the things in a better manner. Yes. Let's move forward. So these nitro compounds can be reduced to the amines by the catalyst like the palladium and platinum. You can see here from this example very easily. Nitro compounds can also be reduced to amines by reducing them with the metals in the acidic medium. So if you have nitrobenzene, you can convert it into the aniline. And this is what you do either with the hydrogen and palladium in the presence of ethanol. We can even use the metals like tin and iron into the acid HCl, and that can also be used to convert the nitrobenzene to the aniline easily. Nitroalkanes can also be similarly reduced. So if you have nitroethane, that can be converted into ethane 1-amine by the Fe or HCl. You can even use here SN oblique HCl, or you can even use here H2PT, or you can use H2PD, and so on. So this is how we can use, or same way the aliphatic nitro compounds can also be converted into amines by this method. Now let's move forward and understand something something really interesting. Now give reason. For the reduction of the nitro compounds to amines, iron scraps and hydrochloric acids are preferred. So instead of the platinum and palladium like very costly metals, here we are going to prefer the iron scrap, that is Fe oblique HCl. This is the best reagent to convert our nitro compounds into amines. What is the reason? For the reduction of the nitro compound to amines, iron scraps and hydrochloric acid is preferred. Because, what is the reason? Let us look at. Because with the reaction of Fe, with the reaction of Fe and HCl, FeCl2 is formed, which is hydrolyzed to produce HCl again. So FeCl2, which is produced by the reaction of Fe and HCl, which is hydrolyzed, which itself is converted to HCl when it is hydrolyzed, and then we do not need to more. So FeCl2 hydrolyzed to produce HCl. So less amount of acid HCl is needed or required for the reduction, and just enough HCl is required to initiate the reactions. So when we use Fe oblique HCl, HCl is produced during the reaction, and we need to use a very small amount of HCl for this particular reaction, and that is why the iron scrap with HCl is preferred for conversion of the nitro compounds to the amines. Now we want to study a very important method for the preparation of ammonolysis for the preparation of amines. This method is very simple and it seems very useful, but this method gives the mixture of the various amines, and that is why practically or in the industrially this method is not preferred much. Let's move forward and understand the reaction for the ammonolysis of alkyl halides. Uh, an alkyl halide or benzyl halide on reaction with the ethanolic solution of ammonia undergoes the nucleophilic substitution reaction in which halogen atom is replaced by the amino group. So this process of cleavage of the nitrogen and hydrogen, carbon and carbon and halogen bond, that is CX bond by ammonia molecule, is known as the ammonolysis. So once again, the reaction is carried out in the sealed tube, my dear students, so that the required reactants do not go outside at 373 Kelvin, that is 100 degrees centigrade temperature. The primary amine, thus object, behaves like a nucleophile. So first we get the primary amine, and this primary amine even behaves like a nucleophile because it has the nitrogen that has the lone pair of electron present with it, and that is why it behaves like a nucleophile and can further react with the alkyl halide to form the secondary, tertiary, and ultimately the quaternary ammonium salts. So let us look at the reaction so that we can understand it better. Let's understand the reaction. Just have a look to this. First, we have the ammonia, which is the nucleophile that attacks on the alkyl halide, on the alkyl part of alkyl halide, and it forms the RNS3 plus and X minus. This is the substituted ammonium salt. Free amine is obtained by the treatment with the strong base. So this substituted ammonium salt, when it is allowed to react with the sodium hydroxide or base, strong base, we get RNH2, H2O, and NaX. So this is how, my dear students, we understand the reaction that the primary amine is formed this way. So first, in the seal tube, when the alkyl halide and ammonia reacts with each other at 373 Kelvin temperature, first we get the substituted ammonium salt. This substituted ammonium salt, when it is treated with base, we get the primary amine. This primary amine, when reacts with the alkyl halide, it gives us the secondary amine. Secondary amine, when it reacts with the alkyl halide, it gives the tertiary amine. Tertiary amine reacts with the alkyl halide, it gives us the quaternary ammonium salt. So this is how we understand the reaction. Please remember that as it is the mixture of primary, secondary, tertiary, quaternary salts or amines, it is difficult to separate them. Why ammonolysis is not preferred? Why we do not prefer this ammonolysis for the amine preparation? For the preparation of various amines, we generally do not prefer this process which is known as the ammonolysis. What is the reason? Ammonolysis has the disadvantage of yielding a mixture of primary, secondary, tertiary, and quaternary ammonium salts. So as the ammonolysis takes place, we get the primary mixture of primary, secondary, tertiary, and quaternary ammonium salts. However, primary amine is obtained as the major product by taking the large excess of ammonia. But still, so that is why it is not preferred, because it gives us the mixture of amines which is difficult to separate. But you need to remember, or you need to understand that the major product that we get is the primary amine. The order of reactivity of halides for the ammonolysis is alkyl iodide is the most reactive among all the alkyl halides, then alkyl bromide, and then alkyl chlorides. My dear students, alkyl fluorides are not used for the ammonolysis process. Now, my dear students, we have a question. So let us solve this problem. Write the chemical reaction write the chemical reaction for the following reactions. First, reaction of ethanolic ammonia, that is NH3 with C2H5Cl. So my dear students, please remember that when we have C2H5Cl, which is known as the chloroethane reacts with ammonia to first give the ethanamine, which is the primary amine. This primary amine behaves like a nucleophile and attack on the C2H5Cl, that is your alkyl halide, to give us the secondary amine and ethyl ethanamine. Then the secondary amine again reacts with the alkyl halide to gives us the tertiary amines, that is NN diethyl ethanamine, and then when this NN diethyl ethanamine reacts with the alkyl halide, it gives us the quaternary ammonium salt of the triethyl ethanamyl chloride. So this is how, my dear students, we understand. Sorry, my dear students, it should be 4 here. So this is how we get the quaternary ammonium salt, and C2H5 are bonded, 4 C2H5 are bonded to the N plus to give us the quaternary ammonium salt, my dear students. So this is how we understand the final product for the ammonolysis. Same way, my dear students, when we are moving, ammonolysis of the benzyl chloride and the reaction of amine so formed with 2 moles of CH3Cl. So first we do the ammonolysis of benzyl chloride, and then whatever the reaction takes place, we allow it to react with the 2 moles of CH3Cl. So first the ammonolysis of benzyl chloride in the presence of ammonia, my dear students, it gives us the benzylamine. This benzylamine, my dear students, when it reacts with the CH3Cl, when it reacts with the CH3Cl, once 2 CH3Cl, because there are 2 moles of CH3Cl reacts with it, and finally we get NN-dimethyl phenyl methanamine. So NN-dimethyl phenyl methanamine. This is how the product that we get. So here we get the benzylamine because of the reaction with the benzyl chloride to ammonia. When the benzyl chloride reacts with the ammonia, we get the benzylamine, and then benzylamine reacts with the 2 moles of CH3Cl to give us the NN-dimethyl phenyl methanamine. Now, my dear students, after the understanding of the various ammonolysis process, I would like to ask you that is there anything which you could not understand? अगर आपको कुछ समझ में नहीं आया और पूछना है तो आप लोग पूछ सकते हैं, otherwise we'll go for the reduction of nitriles. If you do not understand anything, अगर आपको कुछ समझ में नहीं आया है ये पेजेस में से, तो आप पूछ सकते हैं, जो कि हमने डिस्कस किए हैं. For the preparation of amines, we have first discussed the reduction of nitro compound. For that we use the hydrogen and palladium or platinum, then the metals and HCl. We prefer Fe and HCl. Then because it produces HCl itself, so HCl is used less. Then we have the ammonolysis of alkyl halides. So first ammonolysis, we get the salt, and that salt reacts with the base to give us primary amine, and primary amine reacts with the 1 mole of alkyl halide to give secondary, 2 mole of alkyl halide to give tertiary, and 3 mole of alkyl halide to give us the tertiary or quaternary ammonium salt. So this is how, my dear students, we understand. अगर कुछ पूछना है तो पूछिए बच्चों, या फिर आगे चले. Let us look at the reduction of the nitriles. So let's pay attention to the reduction of the nitriles, my dear students. Nitriles are the compounds where you have the C triple bond end present. So nitriles on reduction with the lithium aluminum hydride, that is LiAlH4, or catalytic hydrogenation, we can do some other catalytic hydrogenation, produces primary amines. So nitriles, either the reaction with the LiAlH4 or other catalytic hydrogenation, it gives us the primary amines. This reaction is used for the ascent of amines. Ascent of amines means decreasing the number of carbon into the amines. So ascent of the amine series, that is for the preparation of amines containing 1 carbon atom more than starting amines. So when we do this, we get the more number of carbon atoms uh, or when we use this reaction, we can get the product that may have the more number of carbon atoms as compared to the previous one. Let us see how does it works. You have the nitrile compound. This nitrile compound, when it is react with the sodium amalgam present into the ethanol, it is reduced by the hydrogen in the presence of nickel, or even we can use the LiAlH for lithium aluminum hydride. So by using this LiAlH4 also, we can produce the methanamine from the, or um, sorry, not methanamine, but alkyl methanamine from the nitride. So RC triple bond N gives us the RCH2NH2. This CH2 is converted, this C is converted to CH2, and this N is converted to NH2. Now we want to convert methanamine to ethanamine. So how do we convert methanamine to ethanamine? This is what it is known as the ascending series, because my dear students, you can easily see here that methanamine contain one carbon, whereas ethanamine contain two carbon. So let us see how we can perform the conversion very easily. This is the question taken from your exercise. You have methanamine, then you allow it to react with Na2 and HCl, so you get the diazonium salt. This diazonium salt, when it reacts with the H2O, it gives us the methanol, which is an alcohol. This alcohol on chlorination with SOCl2 gives us the chloromethane. Chloromethane, when it reacts with the KCN, it gives us the CH3CN. And on reduction of the CH3CN, this carbon is converted to CH2, this nitrogen is converted to NH2, and we get CH3CH2NH2, which is known as the ethanamide. So my dear students, here this is the important question for your exam, and you should understand the conversion of the ascending series properly. Please learn it. Let's move to the next one, which is known as the reduction of amides. So here we are going to reduce the amides. Amides are the compound that have a C double bond O that is bonded with the NH2. So by the amides, they are the RCONH2 on reduction with lithium aluminum hydride gives us the amides. So if you have RCONH2 with the reduction of amide with the lithium aluminum hydride, we get RCH2NH2. This C double bond O is converted to CH2 part. So if you have CH3COCH2 with lithium aluminum hydride, it gives us CH3, CH2NH2. This is what is known as acetamide. It gives us the ethane 1 amide. So this is how, my dear students, we understand the conversion of amide into the uh, amines just by the reduction with the lithium aluminum hydride. Now, my dear students, we are going to study the very important reaction for the preparation of primary amines. So, for the preparation of primary amines, this method is used greatly, but it is used for only the preparation of the primary amine. This method is known as the gabrielphthalamide synthesis. Gabrielphthalamide synthesis is used for the preparation of primary amines. So gabrielphthalamide synthesis is used for the preparation of the primary amines. In gabrielphthalamide synthesis, phthalimide on treatment with the ethanolic potassium hydroxide forms potassium salt of phthalimide. You can see here, this is your phthalimide, benzene, then with the benzene directly bonded C double bond O, and both the C double bond O are bonded through the bridge of NH. This is what it is known as phthalimide. Phthalimide on reaction with the KOS, that is potassium hydroxide, or alkali, it forms the anion, that is the anion formed by the phthalimide. So once again, in gabrielphthalamide synthesis, phthalimide on treatment with ethanolic potassium hydroxide, this potassium hydroxide is ethanolic. You need to remember that the potassium hydroxide is ethanolic. So here we use the ethanolic potassium hydroxide and then we get the anion formed by the phthalimide. This anion on reaction with the RX gives us the alkyl, or that is RX is alkyl halide, and that gives us the N-alkyl phthalimide. Let us go further. So in Gabriel phthalimide on treatment with the ethanolic potassium hydroxide forms the potassium salt of phthalimide, which on heating with the alkyl halide, followed by the alkaline hydrolysis uh, process, produces the corresponding primary amide. So first we allow it to react with the alkyl halide, and then we do the hydrolysis. So on the hydrolysis we get the primary amide. The hydrolysis is basic in nature, so we use the base NaOH here in this process. So my dear students, once again, this is the very simple process to understand that phthalimide first reacts with the ethanolic KOH to gives the anion. You can see the negative charge on nitrogen. Anion formed by the phthalimide in the ethanolic KOH. Then this anion formed by the phthalimide in ethanolic KOH is allowed to react with the alkyl halide, and then after alkyl halide, after the reaction of the alkyl halide, we go for the alkaline hydrolysis, that is the hydrolysis in the presence of the base. So we get the primary amine in this reaction. Now there is a very important reason that we want to study here. What is the reason? Let's read the question. Why secondary, tertiary or aromatic primary amines? Remember, why secondary, tertiary or primary aromatic amines cannot be prepared by the Gabriel-phthalimide synthesis. Once again, we cannot prepare the secondary amine, tertiary amine or aromatic primary amine during or by the process of the Gabriel-phthalimide synthesis. Or why only primary amines can be prepared by the Gabriel-phthalimide synthesis. Let me explain the reason, and then we are going to read the text, my dear students. Here you can see that in Gabriel-phthalimide synthesis, the phthalimide reacts with ethanolic KOH to form the anion, that is anion formed by the phthalimide. This anion, my dear students, this anion reacts with only primary alkyl halide. This anion reacts with only primary alkyl halide. It does not react with the secondary alkyl halide. It does not react with the tertiary alkyl halide, or it does not react with the aromatic halide. So there is no possibility of making secondary, tertiary or aromatic aromatic amines in this process, but we can only prepare the primary amines because only primary alkyl halide reacts with the anion formed by the phthalimide. Once again, only primary alkyl halide reacts with the anion formed by the phthalimide. Secondary, tertiary or phenyl alkyl halide do not react with the anion formed by the phthalimide, and that is why it is not possible to prepare the secondary, tertiary or aromatic primary amine by this method. In Gabriel-phthalimide synthesis, phthalimide is allowed to react with the ethanolic KOH, so that anion is formed by the phthalimide. This anion reacts with only primary alkyl halide, and it does not react with the secondary or tertiary alkyl halide or phenyl alkyl halide, and that is why anion formed by the phthalimide does not react with the secondary alkyl halide, tertiary alkyl halide or aryl alkyl halide, and that is why as the above anions cannot undergo the nucleophilic substitution reaction with the anion formed by the phthalimide, only primary alkyl halide can be prepared by the phthalimide Gabriel-phthalimide synthesis. So now I hope, my dear students, you must have understood the process which is known as the Gabriel-phthalimide synthesis. Now, my dear students, we want to understand a very important reaction which is known as the Hoffmann Bromamide degradation. We call it degradation. To degrade means to decrease. So why do we call it degradation? Because during this process, the number of carbon is being decreased. And as the number of carbon is decreased, we call it a degradation reaction. So once again, the name of the reaction that we are going to study is the Hoffmann Bromamide degradation or Hoffmann Bromamide reaction. Let us understand the Hoffmann Bromamide degradation. Hoffmann developed a method for the preparation of primary amines by treating an amide with the bromine in an aqueous or ethanolic solution of the sodium hydroxide. So my dear students, we here understand Hoffmann developed a method for the preparation of primary amines by treating an amide with bromine in an aqueous or ethanolic solution of sodium hydroxide. In this degradation reaction, migration of migration of an alkyl or aryl group takes place from carbonyl carbon to the carbonyl carbon of amide to the nitrogen atom. See, if you have RC double bond O NH2, after this reaction of Hoffmann bromamide, these R directly get bonded. This R is directly get bonded to the This R is directly get bonded to the nitrogen, my dear students. So R get bonded to the nitrogen. So we get finally product as RNH2. So this R get directly bonded to nitrogen, and that is why we call it migration. The migration of alkyl group, that is R group. R is alkyl group. The migration of alkyl or aryl, R may be alkyl or aryl. This migration of alkyl or aryl group takes place from carbonyl carbon. As R is bonded to the carbonyl carbon, it get directly bonded to the amine. So thus the amine so formed contains one carbon less than that present into the amines. So as the alkyl or aryl group directly get bonded to the nitrogen, and that is why one carbon is decreased into the products. You can see that RCONH2 with bromine and NaOH, it gives us the RNH2. This carbon is being decreased into the products, and that is why we call it Hoffmann bromamide degradation. Now let us understand the Hoffmann bromamide degradation with some example. Suppose you are asked in the exam to convert benzamide to aniline. You want to convert benzamide to aniline. So here you have benzamide, that is C6H5CONH2. You have C6H5CONH2. This CO, by the reaction with bromine and NaOH, is being removed or the migration of this phenyl group takes place on the nitrogen, and we directly get aniline. Apart from that, we get sodium carbonate, sodium bromide, and water molecule. Now, my dear students, we want to study the example of the descending series. So we have seen how we can prepare ethanamine from methanamine, but suppose we want to prepare ethanamine to methanamine. That means if we want to prepare methanamine from ethanamine, we want to have the less number of carbon into the products. So we want to go for the descending series, or we want to decrease the number of carbon. Here we will use the Hoffmann bromamide degradation. So suppose you have ethanamine, you allow it to react with NaNO2 and HCl, and then you get the diazonium salt, and this diazonium salt on reaction with water, it gives us the ethanol. Ethanol, when it is oxidized by the KMnO4 solution, to gives us the ethanoic acid, and ethanoic acid on reaction with ammonia, it gives us the ethanamide. This ethanamide on the Hoffmann bromamide degradation, that is the reaction with Br2 and NaOH, gives us the methanamide. So ethanamide can be easily converted to methanamide by the Hoffmann bromamide degradation. Now next reaction, suppose we want to convert CH3CH2Cl into CH3CH2CH2NH2. You can see that we want to increase the number of carbon here. So how can we increase the number of carbon? Suppose you have chloroethan CH3CH2Cl, you undergo the ethanolic NaCN, and then you get the pentane nitrile. On pentane nitrile reduction, we get propane 1-amine, that this carbon which is added extra is being converted to CH2. So here you can see that we have seen the example of ascending and descending series. This is the example of ascending series. So when we have the ascending series, we use the nitriles, but when we have the descending series, my dear students, we descend the number of carbon from amide to amine by the Hoffmann bromamide degradation. I hope now the increase and decreasing series must have been understood by you people. If you have any doubt, you can stop me at any time and ask. Let us perform some more conversion. C6H5CH2Cl into C6H5CH2CH2NH2. Again, we want to increase one more CH2 here. That is what we can use. It is an ascending series. And for ascending, we have to get the nitrile compound. So C6H5CH2Cl, first in the ethanolic NaCN, we get the phenyl ethane nitrile, so nitrile compound, and this nitrile on reduction will produce an extra CH2 because this carbon is converted to the CH2 and we get 2-phenyl ethanamine. Actually, we had the benzyl chloride or chlorophenyl methanamine that has been converted to 2-phenyl methanamine. Now we have the next question. Write the structure and IUPAC name of the amide which gives the propanamine by the Hoffmann bromide reduction. So we want to get propanamine. So we need to add extra CO here. So we have already added CH3, CH2, CH2. If we add extra CO here, that is the amide that can give the propanamine by the reaction with Br2 and NaOH, and that is what it is known as the butanamide. So my dear students, as we can easily understand that butanamide gives us the propanamide, and that is why the answer of this question is butanamide. IUPAC name is butanamide. Then next question. The amine produced by the Hoffmann bromamide degradation of benzamide. So my dear students, we have already studied that benzamide on the Hoffmann bromamide reduction gives us aniline. This aniline is also called the benzenamide. Let's understand a few more questions, my dear students. How will you convert the benzene to aniline? So to convert benzene into aniline, first we take benzene and do the nitration with the concentrated H2SO4 and HNO3. We get nitrobenzene, and this nitrobenzene, when it allowed to react with the iron and HCl, that is iron scrap and HCl, we get aniline. Same way, my dear students, we want to convert benzene to the N dimethylaniline. So same, first we take the benzene, we do the nitration, so we get nitrobenzene. Then nitrobenzene is converted to aniline by the reaction with the iron scrap and HCl, and then we do the ammonolysis. So we allow the primary amine to undergo the reaction with the alkyl halide, and we get N-methylaniline, and on reaction with the 2-alkyl halide or 2 mole of alkyl halide, we get N-dimethylaniline. So it's easy for you, my dear students, to understand these conversions. Now we have the compound ClCH24 CH2. We want to convert it into the hexane 1,6 diamine. So this compound, which is 1,4-dichlorobutane, we want to convert it into the hexane 1,6 diamine. We first allow it here. We want to increase the number of carbon, my dear students. So here we want to increase the number of 2 carbon. So as we have 2 chloro group, we allow it to react with the ethanolic KCN. So we get 2 nitriles bonded to them. Both these 2 nitriles are reduced by the hydrogen and nickel, and we get hexane 1,6 diamine. So these are the various conversion, my dear students, which I wanted to discuss with you. Let us revise what we have studied today, so that, and if you have any doubt, you can ask me your doubts, my dear students. After the previous discussion, my dear students, we have studied about the reduction of amides. Amides on the reduction, they gives us the amines, because the alkyl or aryl group bonded to the carbonyl carbon simply is bonded to the nitrogen. Then we have studied about the gabrielphthalamide synthesis. In gabrielphthalamide synthesis, phthalimide reacts with the ethanolic KOH to give the anion, and this anion only reacts with the primary alkyl halide to gives us the primary amine. Secondary